In this video, we are simply going to go over a little bit of the notation in chemistry, because at this point, things start to become muddled if we don't try to clarify it. So let's look at this formula. We have 2SO4 3-, and we have three different places where numbers are appearing in chemistry. This number out front is called the coefficient. It is the total amount of moles. You can count it large scale as moles, or you can look at it small scale individually as atoms or molecules. So you could say we had 2 moles of SO4 3-, or you could say we had 2 molecules of SO4 3-. And either one would be correct depending on whether you were looking large scale or small scale. We typically talk in moles because that's something that's large enough for us to be able to see. This little number is a subscript. It is the number of atoms of the element written just before it. So in this case, there's no subscript written here, and when that's the case, it's always 1. But we never write 1s in chemistry. So we would have 1 atom of S and 4 atoms of O in every SO4 3- ion. I called it a molecule earlier, but technically it is an ion because it has a charge. This number up here tells you that it's an ion because it has a charge, and its oxidation state is 3-. It tells you how many electrons are lost or gained per individual ion. So out of these 2 SO4 ions, each one of them has gained 3 electrons. The negative number tells you that it has gained 3 of them, as electrons have a negative charge. So let's do a couple examples. Here we have H2O. So if we were to draw that out, what that looks like is 1 O attached to 2 H's. That 2 goes to the H, not the O. There's no charge written up here, so this molecule is neutral, and there isn't a number out front, and when that happens, it's always just 1. So we have 1 molecule, or 1 mole of H2O. For this example down here, we have 2 CH4s. So what that means is we have 2 molecules, or 2 moles of CH4, depending on what you need. And what that looks like is that means we have, 2 separate CH4 molecules. So that 2 out front means that they're separate molecules. They aren't attached to each other. So if for some reason we were to change that to 1, for once we wouldn't write it, we would just erase the 2 and the 1 is assumed, we would get rid of a whole molecule. And lastly down here we have 4 S2- ions. So what that means is that there are 4 separate S2- ions. So we would have S, 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 S for our total of 4, and each one of those would have a 2- charge. So that gives you a couple of examples, as well as some outright definitions of what all of these numbers mean. And you can always go back to this video at any time for a refresher. All right,